Now, let's focus to example 1. We have integrate of square root 6 minus x squared dx. So, for this question here, you cannot use u substitution. If you let u equal to 6 minus x squared, when you differentiate it, you'll have x as the remainder and you don't have anything outside here to cancel out with that x. Okay, and this is also not associated with inverse trigo, so you cannot use integration of inverse trigo. So the only way to solve this is to use trigonometric substitutions. Let's adjust this question a little bit here. This is just square root of a constant squared minus variable squared. So let's adjust this 6 here. This is just set 6 squared minus x squared. So your a here now is equal to 6. And your variable x, this is the same, x is just equal to your variable x. So now let's use the formula. Let's substitute x equal to a sine theta because this is associated with the equation of sine. X is equal to 6 sine theta. Now let's change everything here in terms of theta. So let's differentiate this. Dx is equal to 6. Differentiate sine is cos theta d theta. So now let's focus on the question. Let's change everything now in terms of theta. So this is just integrate square root of 6 minus, just write it back, square root 6 minus, and this x here. Let us substitute with this trigonometry. So x here is 6 sine theta and put the square here. Now let's exchange our dx. Dx is just 6 cos theta d theta. So now we can see that this is a constant. Let's take it outside. And this is just integrate and square root. Let's open up the square here, expand. So this is just 6 minus 6 square is 6. Sine square is just sine squared theta. And just rewrite back cos theta d theta. So we can see here that 6 here is a common term. So let's factorize 6 out. And you're left with 1 minus sine squared theta. And the rest of it, just rewrite it back. So now we can expand this, okay, we can split. This is a times b, so you can split as cert a, cert b. So let's split this. This is just cert 6, and this is cert 1 minus sine squared theta. So cert 6 is a constant, let's put it outside. So you're left with integrate of cert 1 minus sine squared cos theta d theta. So now let's focus here. We can exchange 1 minus sine squared using trigonometric identities. So sine squared plus cos squared is equal to 1. So we can find 1 minus sine squared is equal to cos squared theta. So let's change everything here. This is equal to cos squared theta. And this is your square root. Cos theta d theta. Let's solve this one. Set 6 times set 6. This is just 6. So now we can cancel out cert and square here. So you're left with cos theta d theta. And let's rewrite back your 6. So this is just integrate cos squared d theta. We have the trigonometric identities here. Cos squared is equal to half in bracket 1 plus cos 2 theta. We have learned this in the previous chapter. So let's substitute this here. So now let's see here, half is a constant. Let's put it outside. So you have 3. And then you are left with integrate of this function here. 1 plus cos 2 theta d theta. So now let's expand this. So you have 3 integrate d theta plus 3 integrate cos 2 theta d theta. So let's solve this. This is just 3 theta plus 3. And let's solve this. Okay, let's use shortcut. Integrate cos 2 theta is sine 2 theta over 2. Okay, let's divide with a further differentiate this function here. So you should put it as over 2. And don't forget to write plus c. So now we have finished integrate this. However, this is not your final answer yet, even though you have finished integrate. Why? Because now all your answers is in terms of theta. We don't want theta, we want to back substitute, and we want our answer to be in terms of x. So what should we do? Let us open up, alright? So how to open up? Let's rewrite back our function just now. X, we let it as cert 6 sine theta. So let's rearrange. Sine theta is just x over cert 6. So you are able to draw a right angle triangle here with one of the angle as theta. So now sine is opposite over hypotenuse. So opposite over hypotenuse, this is just x over cert 6. So here you are able to find the adjacent. Let's open up your adjacent. This is just square root of your hypotenuse squared minus opposite squared. So this is set 6 squared, which is 6, minus x squared. So now we have finished drawing up our triangle. This is very useful to us because we will back substitute the value after this. So now let's focus to our answer just now. So this is 3 theta plus 3 over 2 sine 2 theta plus c. Let's open up sine 2 theta. This is just 2 sine theta cos theta. So now this is a common term. You can cancel out. So now let's open up everything. We have 3 theta plus 3 sine theta cos theta plus c. So now we are ready to substitute the value of theta. And we have sine theta and also we have cos theta. Now we refer to our triangle. So let's rewrite back the question. Integrate of 6 minus x squared dx. And this is our answer in terms of theta. So now let's back substitute everything in terms of x. So you have 3 theta. Let's open up our theta from here. If your sine theta is x over set 6, therefore your theta will be inverse sine x over set 6. So let's rewrite that here. Plus 3. And let's write our sine theta. We already have here. Sine theta is just x over set 6. And after that, we want to substitute cos theta. So from here, let's read the value of our cos theta. So cos theta is actually adjacent over hypotenuse. So let's write this. This is just set 6 minus x squared over set 6. So let's rewrite that here as our cos theta. And please write here plus c. So let us simplify our answer here. The first part is ready. So just rewrite it back. This part here is not ready yet. So set 6 times set 6 is 6. So 3 over 6, this is just 1 over 2. So this is 1 over 2. X times set 6 minus x squared plus c. Therefore, this is our final answer. So don't forget, when you do trigonometric substitution, make sure the final answer is in terms of your original variable, which is x. So that's the end of example 1.